a really fantastic joke, and never to be heard again. Never to be heard again. That was it.
Yeah.
I'm joking. There
I
was no
forgot it
joke.
as well. Sorry, guys.
Right. Welcome back, everybody. It's week 3 of Summer of Nodes. We are back here for hints for the whodunit, the murder mystery. And look who's back.
It's me.
Alex is back.
Good to be back. Good to be back. Yes. Yeah.
Exactly. Right, so in week 3, we're going to do some hints. If you've got some questions that come up, so we're going to do some general hints and tips. If you've got something specific, drop your question in the chat and we'll handle that during the stream. If something comes up to you later after the stream is finished or you're watching the recording, then you can drop us a message in the community forum. So that's community.neo4j.com. Post your question there, we'll come pick it up. So we've got a Summer of Nodes section in there, so look for that, post your question in there. And other than that, let's get cracking. So, week 3, hints. Yay, we like hints. So, straight over, we're going to hand over to Alex, and he's going to be talking about the Beginner's Challenges hints.
Perfect. Thank you, Lou. Yes, maybe quickly a little overview on the slide before I'd like to go into a browser to show you a few things. But I think a couple of these queries should help you with what we're looking for, or what you're looking for as Sherlock Holmes in the murders mystery this week. If you query something and use like a contains function here in the first example, you add contains to your query, and that is a string, and that string will then be queried towards the properties of the node, and then you can see if that part of the string, or that string you mentioned here, is part of the property value you mentioned before. I will show you something in a little bit. Then there is the possibility to order your results. I think that might be interesting for you as well for the challenge. You can order in either ascending or descending by using the order by value. So if you look here towards the end, you return something. In this case, return my value. My val is the property you're returning, and then you order it by the value really of the property in descending order by adding this DESC at the end. You could also add an ASC at the end, and then you would it would be in ascending order. So depending on what you think is most relevant or more interesting for you, you can order that. And I think that's a good hint for one of the queries you will have to write. And then the two lower, I think, is that really?
It depends.
Depends, yes.
It depends.
Yeah.
So this is more of a, you don't really need to lower. So if you're very mindful of the cases being used, so if there's a name that starts with a capital letter, or if you're looking at something in the middle of the sentence and it's lowercase, then you're fine. But sometimes if you just keep doing something and nothing's being returned and you're like, what's going on? Maybe the cases are at play. So that might be sort of like it's not very the performant way of doing it, but it's a lazy way of just making sure that, if you're banging your head against a brick wall, why is it not returning anything? It should be returning something. You've checked the spelling, you've checked everything else, check the case. So it's just that. So you don't need it for the purposes of doing this, but if you just keep the stars aren't aligning and it's not quite working out, check the cases.
Yeah. That's a good point. Yes. Can we switch over to?
Absolutely.
So I already loaded the data into a browser or into desktop here and started a database. If you want to know how to do this, watch the recording from last week's hint section where I did it step by step how to do it, how to get the data in. It's basically the same. You just use the code we provide and then copy it over. So I won't be doing this today. But if you struggle a little bit how to get it done, look at the recording from last week. I wanted to start with a little a reminder of the model. So I think we showed this last time, but just again, so you I think it's relevant. If you can look at that if you when you look at the code which we provide to load the data. But if you struggle a little bit, just use the DB schema visualization prompt, which gives you the schema of the graph, and then you can see all the values here and all the properties of the nodes and the relationships in our graph, and then you can click on each of the nodes. So let's say, for example, we click on vehicle, and then you will also be informed about the properties that these nodes have. So, for example, this vehicle node has a property name and really nothing else. And for example, the person node has the property name as well. And these other values here. So I think that's helpful for people to get started, I think, and to find a little bit what you want to do. What I wanted to show you here today, just quickly, is if you struggle a little bit how to get started, what is really where do we go about? You have also here the node labels and relationship types in the top left corner. If you click this database icon, and you see everything here as well. If you don't remember this, I think we gave you a hint and say you start with the crime scene report of 15th January 2018. So I'll not go there, but I'll show you some things, so a little bit of what to do. So we want to match something. We match a crime scene report. And here I wanted to show you something. So let's say we use the where, and that's the name. So no, wrong, city. I think it should be city. City?
Yes, city.
Yeah, it's city. So we wanted you wanted to know the crime scene report from that date, from that city, and the city was Gruffville, I think, but there's another city here as well, which is called, I forgot the name now, Riverville or something. I think. Let me return some numbers, and then I will remember because I forgot now. It was. Let's say Albany. Here is a good example. Here, city is Albany. Okay, so we go here. And we want to know where city is Albany. So here again, So here we have this little work clause where we say, okay, the property city needs to be Albany and we specify this here. And then we call the city back, and we get all the crime scene reports that have the city Albany on them. So in this case, it's just one, which is not an ideal example. I wanted to show you a little bit more, but I forgot the other name, which I checked earlier. But you can, you can do whatever. We can replace this really.
Why not do this as an example of using the order by? So if you do match C and then do return distinct c.city order by city.name, then like that we get a list of the cities. So
oh yeah, true.
You could do an example of the order by clause. So if you do c.city, I think, because otherwise we just get the nodes back. So like this, we just want to bring back a tabular list of results. Lovely. So that's going to give us reverse alphabetical order. Aha, look at that. So if you put a distinct in there, then it will just return one of each city.
Here?
Yep, perfect. Lovely. No, you don't need a bracket. No bracket.
No bracket? Okay.
No bracket. That's lovely.
All right, perfect. Yeah, exactly. So now we get all the city names, and it's quite a lot. So you can scroll down, and we can pick whatever city we think is is the one we need, and then look for that in particular and return all the crime scene reports from that particular city. If we indeed found the city that has the crime scene report, and then we can maybe we can, if we go here again, now we know, okay, we look for this particular city, we can string this together. So we can even say, okay, city needs to be Albany and something else needs to be this and that. So we can use an and here and can narrow it down for some other property. So if you remember, let me scroll down here a little bit. If you click on the crime scene report of one, you have the description, you have a date, you have the city, obviously, and you have the type of the incident here, in this case, a murder as well, but in Albany, so wrong city. So you can narrow it down and find some more information about this, and then narrow it down to this particular crime scene report you need to find. Okay. And if you have something you found, interesting, I think for this particularly, for this challenge, I think was for me at least was helpful, was to pin queries. So you can click this button here, and then this query is pinned to the top, and it won't be lost. So if you have found something during your investigation, I think, oh, this is interesting, this is a witness, or this is the right city, and blah blah blah, then pin it here, and then you can come back to it later. You don't have to search for it, and you don't have to rerun your queries again. You can just look into what you found before, like basically like your notes, if you will, for your investigation.
So that's super useful if you happen to put in the crime scene report and you discover there's more than one lead that you need to follow up. So rather than to rerun that query over and over, or write it down on a bit of paper, you can just pin it at the top, and it's easy reference.
Exactly. And then one more thing I wanted to show is let's load some persons. So now it stays here at the top, but I'll unpin this. I close it even. We don't need this now. And we have all these people here, and if we want to look for a specific person, let's say we look for somebody called Leslie here. We'll take this one here, the Leslie. We type in match person, where the name, and then we use the starts with query and say Leslie. Now we have the person that starts with Leslie. We should get all of them. You see, 9 people in the whole database are called Leslie something, and from here we can go and investigate further. We have other features here. We have their address numbers. We have their street here. We have their full name and their social security number. And depending what kind of information we have and what we find out during the investigation, we might be able to narrow it down further. And like before, we can always string this together. So we could even say, if we want to find this one, because we know that this Leslie Demari lives in Lamb Avenue, we can even say p. address street is the Lamb Avenue, and then we will get only this one person node, because we have narrowed it down further, and we can find out more about them. If you want to expand it, you can always double click, then you get all the information that is available for this one person. So we have here a license. They are for some reason not license number, or a Facebook event. So we can call this event name, so they were empty. And maybe this one is another good example here. Because I think this is interesting. If you click on a node and it has further information or further properties which are not visible because it goes over one line, there is this little arrow to the right-hand side, and you can click on it, and it will expand. So it will show you more information about the node. So in particular, the interviews tend to be longer than one line sometimes, and it cuts it off. And you just this one doesn't, but you can just, if there were cut off, then you can just click on this arrow which would appear here to the right, and it would expand more, and then you would be able to read the full detail of it. So if I load some crime scene reports here just quickly to give you some information, we can here, this is a good example. You see here the crime scene starts here and then it goes on. It would go on, but we don't know what's going on here. We click here, and then we can see the rest of the whole text. So I think this is a good tip, because it might be overlooked, and then you wouldn't know, because then you miss half of the information you need for your further investigation.
Indeed.
And I think this is actually all I wanted to show here. I think this is not a really tough challenge. If you really struggle still, like you said, post in chat or write a post blog in the forums, so you get help. But if you start with the crime scene crime scene report of the date we specified from the city and look for type murder, then you will find exactly one crime scene report, and then you can go from there, and it should be fairly easy to navigate through the notes.
And even without the type, I think there's only 3 crimes that happened at Grafville on that day. So you can do the Alex trick where you hover your mouse over each of the nodes and see which one's got type of murder.
You could. But I mean, try to write some queries. I mean, it's more fun that way, and otherwise you will have to look across all these nodes and look for things, which is not, I mean, you can do it, of course, but it's a little more tedious. So, and with Neo4j at your fingertips, like I said, I mean, it's more fun and gets you there quicker.
Yeah, and it's going to be useful. All of these skills that you're picking up now are going to be useful for next week. So keep at it, keep chipping away. You've got this.
Yep.
Cool. Right, let's have a look at the experience challenge. So, what we wanted you to do, so you also need to solve the murder. So you're going to identify the culprits and the original witnesses. And then what we wanted you to do is to identify other potential witnesses based on effectively using weakly connected components. So I'm going to very quickly say I apologise, I didn't make it very clear. So what you need to do is with the gym check-in, so you can do this with just using the Facebook check-in event. So this is all a fluke of the data, and this is an opportunity for you to sort of explore the graph algorithms in a novel way. So I apologise in advance. If you use all of the gym check-in dates, then you end up with a massive community. So don't do that. So please just use the check-in date. You will get, so if you're sitting there going, what's she talking about check-in? This will all make sense as you go through the challenge. But you can solve this just off the Facebook events as well. So effectively what we want to do is we are going to be using weakly connected components. So that is one of the graph data science procedures.
Algorithms?
Algorithms, yes. And for you to do this, you need to think about how you're going to reshape your graph. Because what we've got here is we've got a graph with lots of different types of node and relationships and all that kind of thing. And what we'd like you to do is to think about, certainly for weakly connected components, in this situation, we're trying to figure out how people are connected to other people. So what effectively we need to do is we need to figure out how do we relate this relationship, where if you think about what's going on here, we've got person, has a Get Fit Now membership, checked in a gym, goes back to another Get Fit Now membership that is owned by another person, and same idea with the Facebook event. So you've got a person who checked in at a Facebook event, and that same event was attended by another person who checked in. So what we want to do is we want to take this data and turn it into what we call a monopartite graph. So this is where you've got one type of node. And in this case it's persons. This is all about looking at how people are connected to other people. And in this example, people may be connected or encountered people based on whether they saw them at the gym on a particular day or at a Facebook event. So what we really want you to do, so you don't necessarily have to do the gym site. If you do, please only do it for a specific date, which you will know if you've been through the problem, and do it for all Facebook events. So effectively what we're trying to do is turn this into this, and we can do that when we create our graph projection. So what I'm going to do as well is I'm going to jump into Sandbox. So I've got a Sandbox here which I've already cleaned up and I've put in the data. So again, we can remind ourselves of the data model. Oh, I've done it.
Yeah, I think that the looking into the data model is always a good example to refresh your mind and to think, oh, what actually is there for beginners and for experience alike. I think it's it gets you it reminds you basically what's going on in the database, and then you will find your stepstones basically how to proceed in the investigation.
Absolutely. And you can see here, so we're not going to do anything with interview, not going to do anything with license, not going to do anything with vehicle. What we're doing is we want to somehow create a loop back to person based on this pivot point here, so this get fit now check-in, and we want to do a loop back to person here via the Facebook event. So this one's only for the date. Again, you don't have to do it, you can just do it for that. And I'm not going to give you the example query because I think I'm pretty much going to be giving away the answer. Right, so somebody's made a question about the projections. You can't specify a date for a native projection. No, so you will be using a cipher projection. So I'm going to give you I'm going to show you the layout of creating that graph. So let's do this. If I'm going to create the projection, I'm going to do call GDS, and I just do cipher and it immediately estimates that. So I'm going to be creating a graph projection, but I'm going to be using cipher for doing this because cipher will allow me to do that fine-grained drilling in. Because the other thing as well with the native projection assumes you've got all of your relationships in order, where here we don't. So theoretically, one approach you could use if you wanted to do the native projection for your graph is you could create a new relationship. So you could do like a couple of cipher queries. You could do one cipher query which links person back to person based on them being at the same Facebook event, and you could create another relationship. So the relationship with the same relationship types, exactly, the pre-processing. So you're doing the pre-processing with the other one, you could do the relationship with your filter, and then you could natively load that. The graph is so small, the data is so small, I'm quite happy to just jump straight into using a cipher projection. So a cipher projection is slower than a native projection, but this data set is so small, it'll load in like not even seconds. So it's very quick. So I'm just going to quickly remind you of what it looks like when we're doing a graph projection into memory using cipher. So what we do, we need to provide 3 parameters. So the first one is we need to give our graph a name, and I'm going to give it the very imaginative name of graph. There we go. I know, you were all on the corner of your seats wondering what I was going to name my graph projection, and I've called it graph. Shocking. So we've got our graph projection, and then the next bit we need to provide is to let the projection, what nodes do we want in our projection. So this is a monopartite graph, so I'm providing person. What you can do as well, this is completely beyond the remit of this session, but let's say we had a person node, and we had a customer node, and we had a gym goer node, and all had different names. You could do something like union or something, and just say treat these all as the same node as your cipher projection. So anything that you can wrangle and cipher and spit out, you can use for your graph projection. But that is beyond the scope of this video. Maybe one for another video in the future where we're not talking about whodunit. But anyway, back we go. So the first thing I want to do is provide the nodes for my graph projection. So I'm going to do match P. This is very easy. We want all the person nodes, so match P person, and then I return IDP. So what we need to do, we need to provide the node IDs, and we need to call them ID. So this is what the cipher graph projection loader is looking for. So it's looking for IDs to return. So that's what we're doing. So we're saying match all of the person nodes, and we're going to return the internal load IDs as ID, and then the procedure knows what's to do with that. And then the next thing we need to provide is we need to provide the Cypher query that's going to let it know what the relationships are. So how am I going to do this? Can I do an example? So let's say I wanted to do a query, and this query is going to be completely useless for the purposes of answering this question, but just to give you an example. So let's say I wanted to match people based on them living in the same city, as an example. So what I might do in this example, if I wanted to do that, I would do something like match P1 person. I could actually, I was hoping I could do that. That's fine. This will do. Match P1 person, P2 person. I've obviously didn't think this through prior to the video, but it's good. It makes sense in my head, so I'm sure it's all. So we can't do crime scene because that's not connected. So let's do vehicles. Let's do vehicles that've got the same. I think we had vehicle make, didn't we? So let's say we want to know if people have got the same vehicle make. So let's do.
I think yeah.
Drives.
Car model, I think, or car make.
Model. That'll do. Okay, so let's do V1 vehicle. Let's put some new lines to make it a bit neater. Drives. V2. So this query is a lot more cumbersome because we have vehicle model as a property, not as a node. If we had it as a node, we could just use that node as a pivot point. Because we don't, this is a slightly more involved query, but this is just to give you an idea of what's going on and what you can do. So
it's a hint, not the solution.
Sorry?
It's a hint, not the solution.
Exactly. This is a hint to show you the art of the possible. But this query is completely. You would not be able to copy this query and just substitute things for the purposes of answering the question. So you can't cheat. But I'm just giving you an idea. So let's say where we're going to say that P1 is not equal to P2. So we're not comparing against the same person, and we want to say V1 dot model is equal to V2 dot model. So that's how we're linking them together. So this is how we're connecting those people. So we're connecting them, creating this faux relationship, but exactly by car model.
Car model.
So that's how we're instructing. So this is where our virtual relationship would be. So those of you who've used APOC with virtual relationships, you'd be like, I get this. I see where she's going with this. We're creating like this virtual relationship between these two nodes. And then what the algorithm wants back from us with regards to relationships is to say, what was the source node? What was the target node? So that's basically saying, which node was where was the relationship outbound to inbound? So here we would do return ID P1 as source, and then ID P2 as target. So you can see what I've done there. So I've got something where I'm effectively saying this is how I'd create my virtual relationship. So this will probably make more sense when you're thinking about, well, how do I filter down the specific gym day that I'm being asked to do, if you decide to go down the route. So you don't need to do that, you can just go via the Facebook check-in, but it might be a bit of fun to test your cipher moulding prowess with this. So creating like this virtual relationship via people who drive the same model of car, and then we're giving that back. So that's how I've created my graph. So what I can do, so I've given a very exciting name for my projection called graph. I've got the first
Lou,
part
sorry, Lou, but the property is called car model.
Car model.
Car model.
Okay.
Yeah.
Like that, I guess.
With a capital M.
Perfect. Oh, we've updated it. So you've got the first part of the query that's saying what what are the nodes I want to use as part of my projection, so that's person. Second part wants to say, well, how do we want to connect these nodes that we've provided? And here we're saying we want to connect them by people who drive the same car model. That's what we've done. And this is our projection. So if I hit run here, hopefully this will create my projection. And then if I wanted to go off and now do some kind of run a graph algorithm on that, I could. So I can't to mind think of an obvious one that I would run right now, because this isn't an obvious question I can answer with this. But I was just giving you an example of how I do that projection. And then with regards to weakly connected components, just check out the graph data science documentation there. So you get a very simple example, because all you need to do is stream the results. So you're going to stream the results. You are going to yield some value. So you need to yield the ID node, because it's going to give them as groups. And what I suggest you do is order the yielded value in descending order. So you want to bring back the biggest communities first, because that will make your life a lot easier. And then what you'll do is you'll get a list of names, and I would like you to provide. So if you get a massive list of names, it's gone wrong. You should only have you should have a few number of names. And once you've removed the perpetrators and the original witnesses, you'll have a very, very, very few number of names left. And we'd like you to provide those names for your answer. And this is just a fluke of the database. A little bit of fun for you to dip your toe in the water with using the graph data science algorithms. And for a bit of fun, do explore how they've been linked together. So it might be interesting to see how that's worked, why have they been joined together. But that's on the experience challenge. So again, if you've got any questions, we'll be hanging around for a few minutes on the chat if you want to put anything. Otherwise, do reach out to us on the community forum and we'll get back to you there.
Yep.
And good luck.
Perfect, exactly. Good luck, everybody. Do send in some of your answers. Looking forward to seeing what you find out and what your culprits are.
Yes, who are the perpetrators, the perps?
Yep.
So, without further ado, we wish you best of luck, and we'll see you on Monday.
Best of luck.